Hello everyone and welcome to lesson number 3 in PHP Programming. Now in this lesson I'm going to teach you about the different data types available within PHP. And the purpose of this lesson is to start as a base point for you to go and do some investigation and some experimenting with the different options and the different data types within your PHP scripts. You could do things like comparison, loose and strict comparison, string concatenation, looping through arrays and objects, image manipulation. There's lots of different things you can do, once you've got a solid understanding of the different data types and the different options. Then you can go off and have a little practice and just see what you come up with. And I'll provide a link to the PHP website that you can do some further reading to expand on the base knowledge that you gain from this tutorial. And also I will provide a link to a GitHub repo that will contain the source code that is mentioned. So any source code I mentioned in this video, there'll be a GitHub repo where you can go and grab that, whether you want to do it before you watch the tutorial, so you got the code there when you're going through it, or maybe afterwards, you want something there as a reference to help you understand it better. You can play around with the code itself that's already there. Whatever you want to do, the source code is there for you to go and grab. So I'm going to get started right away. The first data type I'm going to talk about is Boolean. Now Boolean has two possible values, and that is true and false. So it is either true or it's false, and for that reason it's particularly well suited for control structures, because of course in a control structure, an if-else statement, either something's true or it's not. So, and if it is true, you proceed one way. If it's not, you proceed another way. As simple as that. So, I'll show you a couple of comparisons, a couple of functions I created. The first one is loose comparison. Now, it's called loose comparison because it's comparing the value but not the type. And what that means is, for example, the value 1 will be equal to true in a loose comparison because they're seen as equal, but of course not of the same type. A value of 0 will be seen as equal to a Boolean false. Yep, not as the same type, but the same value essentially. Now this second function called strong comparison compares not only the value but also the type. So this check here, if value equals true, will only pass if value is equal to true and is the same type as true. So that is Boolean. So it's of type Boolean. And likewise, this will only pass, this check here, if the value is equal to false and also is of type Boolean. So it's of the same type as false, which is Boolean. And then this here is the default. So if it's equal to true and of the same type as true, then this line of code here will be executed. If it's equal to false and of the same type as false, then this line of code will be executed. And if it is neither of those, if both of those checks fail, then this code is executed. So you could see this code as like a default. If nothing else passes, then that's like a fallback that will get executed. And then we got another function here that casts a value to Boolean. So whatever value is passed in, it will cast it to the Boolean type. So further down the file, we have a few calls to the functions. We have 2 calls to the loose comparison function, passing in true and then false. And then we have 3 calls to the strong comparison function, passing in true, then false, then the string neither. So that's 5 function calls we've got here, and I'll go over to another window and we'll see the result of that. So we can see here the first loose comparison of true is true because true is equal to true, and then the second loose comparison of false is false. That of course false is equal to false, so that's what happens there. We can see that that line of code is executed, or the function that line of code that prints this is executed. And then we have a strong comparison of true, and of course it is equal to true because it's of type, it's equal to true and also of type true. of type Boolean. So this comparison here is checking, are the two values equal and are they of the same type? And of course they're both equal. Yeah, they're both true and they're both of type Boolean. So that's why we're seeing that result here. And then equally, when we pass in false, when it gets that line of code that checks the if statement that checks is false equal to false and of the same type, of course that check is going to pass, and that is why we're seeing this line of this statement here printed, because it is false. Both are false and both are of type Boolean. And then the final one where we passed in neither, of course that is not going to be equal to true or false, because it's not equal to them and it's not of the same type as either of them. So if we ran this check through a loose comparison, it would evaluate to equal to false, because it will get its it will be interpreted as the correct type as 0 essentially, so that will evaluate to false. So let's see what else we got. We got some other stuff in here. So this is another thing that you can do with if statements, control structures essentially, is you can pass in an expression that will evaluate to either true or false. So here we're getting the date, and then we're getting just the hour of the day in 24-hour format, and then we're checking, is the current hour of the day less than 12? Because of course if it's less than 12, that is midday, then it is morning time, because it's before midday, it's before 12, so that is morning time. So we will print out this message here, good morning, and if not, then it's the afternoon. So you can do stuff like that with control structures, essentially an expression that will evaluate to true or false, and then you proceed accordingly depending on what the result of the expression is. So then we got a few more calls to the functions. We got a call to loose comparison with the integer 0, and then loose comparison with the integer 1. And then we have a call to the strong comparison function for both of those values again. So it's loose comparison 0, 1, strong comparison 0, 1. So let's see what the result of that is. We can see 0 and 1, check. 0 is equal to false in the loose comparison because the value is equal to false, and 1 is equal to true. But you can see when we check it in a strong comparison, it's returning the type, because of course it is not equal and of the same type as true, and it's not equal and as of the same type as false, and then the same with 1 essentially. So just to make that clear, I'll show you the piece of code that is executed. So here we can see that we're passing in these values 0, 1 to this function, this checking, is it equal to true and of the same type? And it is not. And then we're checking, is it equal to false and of the same type? And it's not. So it defaults to this line, which outputs the value that's passed in, and also outputs the type of that value, which is of integer, which is why it's failing, because of course if it was just a check for the value, then it would pass one of these checks. If it was 1, it would pass this check if this was just the value, and if it was 0, it would pass this check if we was just checking the value. But because of this extra equal sign here, that checks the type as well, not just the value. And of course true and false is of type Boolean, but the 0 and 1 that we're passing in is of type integer, so the check fails and it defaults to this line of code here. Now what have we got next? We have the same check but with the string 0 and the string 1 in loose comparison, and then the string 0 and the string 1 in strong comparison. So we'll see the result of that now. We can see here 0, 1, it's made clear that it's a string because I've put it in between quotes so we know what it is. And then we can see 0 is false, 1 is true in a loose comparison, because comparing the value they are equal. 0 is equal to false and 1 is equal to true. But when we check the strong comparison, it defaults to the last line because of course it is not of the same type. Yep, it might be equal to false, but it is not of the same type. It's a string. It's of type string, and false is of type boolean. And equally, 1 is of type string and true is of type boolean. So that check fails when we're checking if it's true, and if it's false, it fails. Next, we're going to move on to typecasting, because you can cast values to a certain type, and of course in this case we're casting it to boolean. So if we go to this function here, just to recap what it does, this here, this bool in between brackets, casts this value to boolean. Whatever we pass in, it casts it to boolean, and then we're checking, does that, when it's casted to boolean, does it evaluate to true? If not, then it evaluates to false. So it's either going to evaluate to true or false. So we're checking that with various values. We're checking it with an empty string, we're checking it with null, we're checking it with the integer 0, we're checking it with the string 0, we're checking it with an empty array, we're checking it with the integer 1, we're checking it with the string 1, we're checking it with a negative number, -2, we're checking it with a string foo, we're checking it with a float, we're checking it with an array that has a value as opposed to this empty array, and finally we're checking it with the string false. And we'll see the result of all those now. So we can see that an empty string here casts to false. So when we cast that empty string to a boolean, it evaluates to false. Then we're casting null, which casts to false. So when we cast the null to a type boolean, the null value to type boolean, it results in false. Then we cast the integer 0, which also results in false. The string 0 results in false. An empty array results in false, so cast to false. Then 1 casts to true, the integer 1 that is. String 1 casts to true. -2 casts to true. Foo casts to true. The decimal, the float value casts to true, a non-empty array casts to true, and the string false casts to true as well. So moving on from boolean, we move on to the, let me see, integer value type. Now, integer is a whole number, essentially. Yeah, so an integer can be negative, it can be positive, or 0. And an integer can be specified in base 10. So base 10 is the numbers, that is the numerical system that human beings are used to, and for the majority of human beings it's really the only one they know. It's what we're taught in school. It's called base 10 because there are 10 different digits, 0 through 9, and it's the way we are taught to use numbers pretty much our whole life. Yeah, and only moving on from that in detail if we choose maths or if we choose to study certain types of maths. But for majority of people, base 10 is the numerical system they're used to, and at least the majority of adults, I'd say, it's really the only one they know, at least in detail anyway. And then we have, you can use the hexadecimal notation, which is base 16, which is has the same digits as base 10, but then also has alpha characters, which is will be 0 to 9. Then it will be let me think, A, 10, B, C, D, E, F. Yeah. Yeah, that's, I believe, and G. Yeah. Actually, no, sorry. A to F. And then we have Octal, which is base 8. So, of course, that has 8 different digits. And the way that works is once you get to, instead of course, when you're using base 10, when you get to 9, yep, then that column goes back to 0. And then you have a 1 in the column to the left. So that's how it works with base 8. With base 8, once you get to the 8th digit, which is number 7, then that column goes to 0, and you get a 1 in the column to the left. So they work in that sense. They work in the same way, of course, but there's just more digits in base 10. And then you have binary, which is the 4th notation that you can use, and of course that is base 2. I'd say more people have heard of this binary because it's ones and zeros, and it's how computer systems work at their core. It's how they calculate things, how they store data. So I'd say quite a lot of people have heard of this, but they don't really understand it in detail. So those are the 4 options for the different notations you can use with integers in PHP. Now, if you want to use Octal, then any number you use, you have to precede it with a 0. If you want to use hexadecimal, then you precede your numbers with a 0 and an X, and then that's a lowercase x. And then if you want to use binary, then you precede your numbers with a 0 and a lowercase b. But when you print a value, it will always print an integer in decimal in notation, which is base 10, of course. So now I've done a little bit of theory with you, we will look at some code. And essentially we're just going to display different values. And so of course, yeah, we're going to display some different values. So we've got the number 1, 2, 3, 4, which you can probably guess is an integer of type of the decimal notation, base 10. And then we've got the number negative 1, 2, 3, 4, which again is of base 10 decimal notation. Then we have 0, 1, 2, 3, 4, which, if you remember what I mentioned earlier, is of type octal because it's preceded with a 0. Then we have the number 0x 1, 2, 3, 4, which is of course of type hexadecimal. So as I mentioned, hexadecimal numbers, you need to precede them with 0x. And then for this last one is binary, because as I said about binary, you need to precede the number with 0b. So yep, and then there are some constants available in PHP which will tell you different information about your integers. So of course you got PHP integer size, then you got PHP integer minimum, which is the lowest value for an integer that you're allowed with this build of PHP. And then you have PHP int max, the PHP int max constant, which of course is the maximum value available in PHP or in this build of PHP, because of course because that can depend on the machine. It can depend on a few things, you know, but that will let you know this particular build of PHP on this machine, what are the max, the minimum, the maximum, etc. Then we're outputting the string, and I'll say now, if a number is too large to be an integer, then it will be interpreted as a float, so it will be implicitly converted to a float. You know, PHP will do that automatically if the value is too large. So we're outputting these, and yeah, this long number here, this long number here, then a string 0, and then we're going to do some casting. So we can see there are 3 different ways of casting to an integer. You can use the int cast, so here in between brackets you have the word int, which of course is short for integer. Then you can have the full word integer, which of course is similar to this, but you're specifying the full word. And then the third option is to use the int val function. So of course we can see we're doing some casting here. We're casting 0.039, and then we're casting 2.03. Then we're casting a string which has a value of string. Then we're casting the type boolean true, and then we're casting boolean false. Then we're casting an empty array, and finally we're casting a array that has two values in it, but essentially just an array with a value. It can, if it's got a value in, whether it's got 1 or 2 or 3 values, it's going to be interpreted the same in regards to this cast here. So we're going to see the results of these now. Let's move over to integer. So of course we can see this is of type integer. That is correct. This number here is of type integer. This number here is of type integer. This number here is of type integer. 15 is of type integer. 8 is of type integer. So these are the results of the constants. This is PHP. Was it PHP int size? This is PHP int min. So this is the minimum number you can have for an integer. And then this is the maximum, and as you can see, this is negative this amount, and this is positive this amount, and there is just one digit wrong difference. So they go negative and positive to pretty much the same amount. This is a result of that very large value, which of course is too large because it's larger than this number. So I'll just make it clear what I'm talking about. That is this number here, yep, which is larger than the maximum number allowed for an integer. So it is turned into a of type float, which is the same as double. PHP calls it double. Those two words are interchangeable, double and float. So as I mentioned, it's been changed to of type float, and so is the number after it, which is this number here, because again this is too large as well. So they're both turned into float by PHP. Then we're checking some other types that we've tried. So wait, if I look at that, okay, yeah, and then I'm displaying value of type of the string 0, which of course is a string. And then we're casting some values. So 0.039 casts to 0. So as we can see, this is a float, and when you cast it to an integer, it becomes a whole number, a decimal number, as opposed to a floating point number. The same with 2.03. It just takes the first value and it just essentially truncates the value and removes the decimal place and everything after it. The string casts to 0. True casts to 1, false casts to 0. So the same way, if you cast the value 0 to a boolean, so the integer 0 to boolean, it would cast to false, and 1 would cast to boolean true. It's the same the other way. If you cast a boolean true to an integer, it casts to 1, and the boolean false to 0 to integer, it casts to 0. An empty array casts to 0, and an array with a value casts to 1. So the third data type we're going to talk about is float. Now, a float is a number that can contain a fractional part. For example, 1.3, 2.8, 0.240, etc. Floats in PHP have limited precision, so that is a limited amount of numbers after the decimal place, and for that reason they are not particularly reliable if you need exact results. But there are a few ways around that. and I'll show you what I mean. So I've added a couple of functions here. Add numbers together with precision, subtract number with precision. So essentially this just adds the numbers together, but yeah, this adds the numbers together, but you can specify the precision, so the amount of numbers after the decimal point essentially. And similar, when this subtracts the numbers, this just subtracts one number from the other, whereas this subtracts the numbers, one number from the other, but it allows you to specify the precision, so the amount of digits after the decimal point. So then we've got some checks here. So first we're rounding the result of 0.1 plus 0.7 multiplying 10. Then we're so of course this will round it to the nearest whole. Then this floor will take it down, so it will take it down to the nearest whole number. So if it's not a whole number, then it will round it down. Yeah, and then this just prints the result, so it doesn't round it up or down, it just prints the result. Get type. So let's see. So we got 1, 2, 3, 4, 5, 6. Yeah, this is adding numbers together with precision. This is adding numbers together with precision and getting the type. So we'll go to float now. Okay, just to make it a bit more clear, I'm going to add a bit more code. So what are we doing here? Okay, 0.1, but actually I'll make this a string. Okay, now that that's a string, I will just to make it clear what is what on the when viewing this. Just copy that actually, because they're all the same equation, right? 0, 1, 0, 7. Yep, 0, 1, 0, 7. Yep, they're all the same equation. Okay, so let's see the result of all of those equations. So we can see don't need that. That's a much better option. Okay, right, let's look at the result of that. Oh, silly, I didn't put a space, I didn't put any gap, so let's just do that. Right, finally, let's have a look. So we can see that 0.1 plus 0.7 times 10 will result in 8 when we're doing when we're rounding, of course, because it's going to round to the nearest whole. But when we do it with when we run it through the floor function, which essentially rounds down, you would, if you just took a glance at this, you would think that this would result in 8, because 0.1 plus 0.7 equals 0.8 multiplied by 10 equals 8. But that's not the case, because of the way that computers calculate things. It's not to exact precision. So instead of it being 8, it will be something like 7.9222, something like that, something very close to 8 but not quite there. So when you round it, it will round to 8, but when you run it through the floor function, it's going to round it down, which will result in, of course, 7, not 8. So that's why you need to be careful if you're using it and you need exact preciseness. It's not that reliable by itself. You notice that when we run this function, when we run this expression, when we evaluate this query here, 0.1 plus 0.7 is 10, that equals 8. Well, really that is not quite 8, but PHP will truncate the value and essentially output 8. But of course, because when we run it through the floor, we see that actually it really isn't 8. It's very close to 8, but it's not quite there. And when we run it through the function, add numbers together with precision, we'll see the result of this, 0.1, 0.7 to 1 decimal place times 10. We get what we expect, and 8. Second to last. So that is how you can get around that problem, is you use the BC add function, which allows you to specify the precision, so you get what you expect. You would expect 0.1 plus 0.7 precision, one place to multiply 10 to equal 8, and it does if you use the BC add method. And then of course when we use the get type, it returns of type double, which is of type float. So what have we got next? Next we have the result of 0.1 and 0.2, adding the numbers together, 0.1, 0.2, this method here. And then we're outputting the result, and we're checking if the result equals 0.3, then output true. If not, output false. That needs to be there. And yeah, so of course in this case you'd expect it to be 0.3, because 0.1 plus 0.2 should equal 0.3. But again, we'll see the result of that. Add numbers together, 0.1 is false, because it is not exactly 0.3, because again, as I said, the way PHP stores numbers, it stores floats. It's not to exact preciseness. So when we're checking, does it 0.3, does it equal 0.3, it actually doesn't. Even though when I print the result it's saying 0.3, it's not exactly 0.3. And we got the same check but with precision. So we are using the BC add method, add numbers together with precision instead. Then we can see the result of this, which is add numbers together with precision. 0.3 is what the numbers added together show, and it is true, because unlike this where we're showing 0.3, this value has been truncated. So we're not seeing the actual real value, but when you run it through check, it is checking the real value, and of course that's why it results in false. But when you do it with precision by using the BC add method function, it results in true, because it is actually precise. And the same with subtract numbers. So first we're subtracting 6.4 from 8, and then of course you would expect the result to be 1.6. So we're running it through we're just literally subtracting Okay, we want to subtract, not plus, so change that. And so we're just literally subtracting one number from the other, and then after that we're running it through the BC sub function, which is of course the subtracting version of BC add, where you can specify the precision as well. So we'll see the results, the exact same numbers. It's either gonna, when we compare the result to 1.6, which is what we would expect, is either going to be true or false. And as you can see, when we just subtract the numbers, it's false. So even though it's showing us 1.6, it is not exactly 1.6 because it is not exactly precise. When you use floating point numbers with PHP, it is not exactly precise because of the way the computer stored the numbers. But when we run it through the BC sub function and we specify the precision, then we can rely on that value because we're specifying how many numbers are to the right of the decimal place, so we can rely on the result. Now, the fourth data type we're going to talk about is the string. Now, a string is a sequence of characters. There are many ways of creating strings in PHP. For example, you can use single quotes, double quotes, HereDoc syntax, and as of PHP 5.3.0, you can use NowDoc syntax. And just going to double check something. One sec. Yeah, okay, so, and the thing that depending on the type you use, that will affect whether variables are passed, or so whether when you actually have a variable within that string, whether the value is passed, whether it's evaluated, and the data inside that variable is passed and output within the string, or whether it's just the name of the variable is output. So essentially whether that variable is treated as just plain text or whether it's actually passed for its value. And the same with escape sequences and other stuff that is affected. That's all affected by the type of, by how you are creating that string, whether you're using single quotes, double quotes, HereDoc syntax, or NowDoc syntax. And so I'll get started right away with showing you some actual code. So to start off with, I'm gonna show you the single quote syntax. So essentially that is, the string is between single quotes. So here we have the opening quote, then here we have the closing quote, and everything between those quotes is part of the string. Now we can see that number is a variable, but when it's in between single quotes, it's just seen as plain text. So this here is going to have the name of the variable, number. It's not going to have the value of it, which is 2000. It's just going to have the name of it. And if you want to actually add the value within the variable when using single quotes, then you need to concatenate it together. So essentially this is where the string starts with the single quote, then we have this value within the single quote, then we close off the single quote, and we concatenate the variable using the period character, because that's how you concatenate things together in PHP, and then the actual variable. So I'll show you the result of these. And actually finally, within single quotes, we have this string here, and in fact I'll just add it to a new line so it's easier to read. And yeah, let's just move that down. Okay, so there are also escape sequences. So essentially, if you want to put a single quote yeah, an apostrophe or single quote within a string that is itself within single quotes, then you need to escape it with a backslash. So what this backslash does is say that is basically says treat this single quote as its literal character, as a literal single quote, as opposed to actually closing the string off. Because if I remove that single quote, that backslash, then this quote here, this apostrophe, will close off the string and obviously cause an error, because then all of this text here is not within a string anymore, so it's invalid essentially. But if I add that backslash back, then it escapes that single quote, so that single quote will get treated as its literal value. As well as that, you can escape a backslash itself. So if you want this backslash to be treated, if you want a backslash to be treated like its literal value, then you can escape it with another backslash. Now those two are the only escape sequences that work with single quotes. So between single quote, when a string is between single quotes, you can only use those two escape sequences: the backslash apostrophe or the backslash. And I'll show you the result of these two strings, these three strings, I mean. Now, so if we go to string, we can see the number is number. Remember what I said, that the variable will not be passed. We will not see the value within the variable. We will see the name of the variable. So that is what this is here. And then also remember I said that if you want to see the value and you're using single quotes, then you need to concatenate the variable to that string. So you close off the string. You have the opening quote, then the string, the number is in this case, then the closing quote, then the period, then the variable name, and that concatenates that variable. So whatever value is in that variable within it, that concatenates that to the string. And then finally we had the escape sequences. So we had the literal we had the quote, the apostrophe or quote, whatever you want to call it, and it was preceded with a backslash. So essentially that meant that its literal value is output here. Instead of closing the string, its literal value is output. And then also we escaped the backslash itself, which is why this literal backslash is output here. But the rest are just output as plain text. So the other ones are backslash r, which is just output as its text value as plain text rather than its actual value. The same with backslash t, which is horizontal tab. The same with vertical tab, backslash v. The same with escape, backslash e. The same with form feed, which is backslash f. The same with $, which is backslash s, or backslash $, I mean, of course. And the same with the double quote, which is backslash double quote. Because if these escape sequences were interpreted for their special value, then we would not be seeing them output like plain text like they are here. So essentially it's because when they're within single quotes, they're just treated as their literal text, plain text value, what they are, rather than their special meaning. So single quotes are great for certain things, but for passing variables and etc., they're not great, and they're not the way to go. Unless you want to escape things, etc., like escape variable, concatenate variables, but it's much easier to use double quotes. So again, I'm going to in fact, I want that to be there. I'm going to break it there actually, because I want this to be on the same line as the rest of the text. So yeah, so with double quote syntax, stuff like variables, etc., are actually passed within the string. So you don't need to concatenate variables, etc. They will be passed. So, for example, we have this string here. Then we get to this new line character. Now, what this is in PHP is it marks a new line. So when PHP sees this sequence, this escape sequence, it should add a new line, a line return, but only if it's interpreting it for its special value, which because PHP Storm is such a great IDE, we can see that it is, because it's, you can see, you might have noticed that it is blue. Yeah, because it's showing us that it means something. It's not being output as plain text, whereas the same values here. So okay, we haven't got new line, but we got for example, we got \r. Yeah, or all of these, \r, \c, \v, we can see that all of these are just plain text, they're green, whereas here they're blue. So the IDE is essentially showing us that they have a special meaning, and they're being interpreted for their special meaning, not as plain text. So this line here, when we view this in the code, it will be on the new line. It will be on its own line. And all these other values, all these other escape sequences will be treated for their special value, not their literal value, which I'll demonstrate now. So we can see, in fact, it'll be a lot easier if I show you actually in the source code. So we can see, where is it? Strings created with double quotes interpret escape sequences such as new line. Then you can see this will be on the new line, and it is on its own line. So if we looked at the code, it's on the same line as this code, but because of this character here, this escape sequence, it's being put on its own line, which we can see here. It is on its own line. Then we can see carriage return. There's a character it's been interpreted as its special character. That's why it's not being output there. Whereas here we can see it's just being output as plain text, but here it isn't. Same with horizontal tab. Same with vertical tab. Same with escape. Same with form feed. Same with \. But actually \/ was one of the ones that was interpreted in the other one. Same as the $, and same as the double quote. Now, as well as passing the escape sequences for their special meaning, you can also output stuff like variables within double quotes. See here, when we output the variable within the single quotes, it's just treated as plain text. This variable here, you can see it's the name number. It's here. It's just treated as plain text. But when we're outputting it within double quotes, a variable within double quotes, it is interpreting it or passing it for what it contains. So it's not just going to put the name of the variable within the string. It's actually going to pass it and put the results. So whatever's stored in the variable is going to store that within the string, even when it's an array. Essentially, if you have an array, and we're going to move on to what arrays are later on in this tutorial, but if you have an array that has a named key, then you need to put it within these curly brackets here for it to be interpreted, because you wouldn't otherwise. For example, you couldn't do that because PHP, essentially that will return an error. But if you put it between curly braces, then it's fine. And another benefit of that is, if you wanted to output it in a way where you're adding another character directly after the name, for example, if you did that, it wouldn't interpret it. It will cause an error. But even if it wouldn't cause an error, for example, say okay, yeah, here's an example here. Say I want to have an S directly after the contents of this food variable, which in this case is cheesecake. So I want to make it cheesecakes. If I remove them curly braces, it's not going to return an error, but the variable is undefined, so because it's looking for a variable named foods now, not food. But if I add the curly braces back, then we can add characters directly after the variable is passed. So this will be interpreted as this will be output as cheesecakes. So I'll show you the result of that now. Yeah, we can see when within double quotes, strings can pass array variables like so. One Bentley, you can see the first value is 1. That's what is being output here, and then the this value here is car with the array key car is Bentley, and that is being output here. Same with here, that I lost the Bentley's key fob. That is where we've added the apostrophe S right after the value. And then finally we'll look at this one. He ate too many food with S at the end, so passing the food variable and then S at the end, and that is here. He ate too many cheesecakes. So you can see straight away there's a lot more you can do when you're using double quotes, stuff with variables, with arrays, etc., as opposed to using single quotes. You can even output class, you can output data from within a class, so class properties essentially, which we can see here. When using double quotes, you can also pass object properties like so. And yeah, I'm just gonna put a quick line return there so we can see that. And yeah, when passing an array inside of a class property requires braces. So when you're passing an array that's inside a class property, you need the braces for it to be interpreted correctly. You need the curly brackets around it. So let's just see the result of that, and that is here. When using double quotes, you can also pass object properties like so. Foo was the value inside the object property, which we can see here, and then the value of bar is an array, so we'll see we're also outputting that, and we can see bar 1, bar 2, bar 3. Passing an array inside a class property requires braces. So next we're going to move on to the HereDoc syntax, and just to make it clear what the HereDoc syntax allows you to do is it is pretty much identical to the double quotes, but of course you don't need the double quotes. So HereDoc is introduced with 3 left arrows and then a value after that. Just bear with me one moment. Yeah, HereDoc syntax. You have the 3 left arrows to identify the beginning of it, and then you have an identifier, which in this case we're using EOT, so the value EOT, and then you'll have a line return, and then you'll have your value, and then you'll have another line return, and you'll have the closing identifier. So it opens here, it closes here, and this must be right up against the edge. There cannot be spaces. It's not valid if you add a space here. It just interprets it as part of the string. So you need it to be right on the left edge, and then anything within that is passed. So exactly the same as within double quotes. So you can pass variables, you can pass arrays. Inside variables you can pass objects, object properties, arrays inside object properties, etc. Everything that you could pass within the double quoted strings, within a string within a double quote, what we just went through, you can do exactly the same thing with the HereDoc syntax. The only difference is the way the string is opened and closed. So I'll show you the result of all of this. We can see that's where it starts. This is a string created using the HereDoc syntax. We're passing the variable, we're passing the same variable here, but within the braces. We're passing a property, so a property is a variable within an object, and that is what we're passing here. And again, we're passing an array, which is inside a property within an object. So we can see HereDoc syntax. You can pass variables within HereDocs like so. Cheesecake was stored in the variable. How many cheesecakes? This was within the variable. Or actually, cheesecake is, and then the S is on the end, added on the end. We're passing the property. We're passing the object property, which has this value here, and then we're also passing another object property, or 3 more actually, or actually no, 1 more that contains an array, with the values bar1, bar2 and bar3. Now the last option you have is the NowDoc syntax, which is available since PHP 5.3.0, what I mentioned earlier. And for where with the stage we're at now with PHP, that essentially means it's available everywhere, because you know you shouldn't really be using a version of PHP that old anyway. We're at version 7.1 now, so you know it's only old legacy systems that will really be using 5.3.0 at this point. Certainly anything that you can creating from this point onwards will be with a much newer version of PHP that has all four of these options. And NowDoc is introduced the same way as HereDoc, but the identifier is within single quotes and it behaves identical to a string within single quotes. So when it comes to passing variables, etc., again, let's just put that into its own line so we can see it better. When it comes to passing variables and array items and blah 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 and objects and stuff, it behaves like a single quoted string, as in anything within the string is treated as its literal value. Yeah, apart from the escape sequence / single quote and / the same as in, I'll just recap here. Except for these two escape sequences, it's treated exactly the same. So it's treated exactly the same as a single quoted string. So that means apart from these two escape sequences, everything is treated as its literal value. Where was we? Just here. Yeah, so we can see all of these variables, they're just being output as their name. They're not being passed. The value within the variable is not going to be in the string. It's that the actual name of the variable will be in the string. And the same with these escape sequences. They're just going to be treated like plain text strings. They're not going to be evaluated for the special value, which is evident because they are just the same color as the rest of the string. They're not being marked by PHP Storm as a special value, because they're just being output as plain text essentially. Now there are some, so actually I'll quickly show you the result of the NowDoc syntax. So yeah, we can see literally all those variables are just being output, their names just being output. We're not seeing any of the values within them. And finally, we have some things that are universal to all of the different ways of creating strings. So essentially we'll put in Word a simple string created using single quotes, and then we're creating it using double quotes, then the HereDoc syntax, and then that is supposed to be within single quotes to mark the so that's the NowDoc syntax, and then we're just displaying those values. So, and what I'll mention is with strings you can access the strings in certain so the characters in certain positions. So we have the string word here. Well, this is the introduction, and then the rest of the string is there. And what we're doing here is we are going to output characters in certain positions, and it's 0 indexed. So what that means is this here, variable 0, is this first character here, the W. This first character here. Then var1 is this second character here, because this is how you can access individual characters, and it's 0 indexed, meaning the first character is at position 0, not 1. So this 0 is the W, 1 is the 0, is the O, 2 is the R, and 3 is the D. So we can see that is output in this WORD. And with string conversion, we'll have a quick look at that now. Right, string conversion var equals 1. So we're printing get type var, and then we're printing get type string var. So we've got var equals, so we've got the first one is an integer and the second one is a string. So in fact, just to true, and then we'll do the same for this, but we'll do string var. So we're outputting with a type of var just as it is when it's entered, so this value here, and then we're outputting it, the result, when we've casted it to a string. And then we can see 1 is integer, so of course when we're just getting the type of the value 1, it is of type integer, but when we're getting the type of the value 1 once we've cast it to a string, it is of course of type string. When we cast true converts to, yeah, so when we, well, that's not really needed. If you convert the, if you cast the boolean true to a string, then we can see that it results in the it results in 1, so the character 1. And then we've got some more values that we're going to cast. Oh, actually, yeah. So the thing with PHP, the thing with strings is that you can cast them to a value to a type string, but a lot of the time it's not necessary, because when you have an equation that needs a different result, so an expression essentially that needs a certain type of a certain data type, I mean, not result. Sorry, let me just quickly organize this. Then it will change it to that result, that data type automatically. So for example, if you was trying to multiply a number by a string, then it would change that the string to a certain type to complete the equation. So here we've got a few equations. We've got 1 plus 10.5, which is a string 10.5, not the number. Then the same 1 plus negative 1.3 E3, 1 plus Bob3, etc. We've got some more here. And then if we see the results of that, we have 11.5 is double, 1 is, yeah, so if we got, when we see the 1 plus 10.5, we can see that results in 11.5, because that string 10.5 is converted to an integer automatically by PHP, because it knows for that expression to be fulfilled it needs a number. It doesn't need a string, so, and it can convert that number, that string, to a number, because it's a string 10.5. So it's easy to convert that to a number, and the result is a float. And the same with the next one, but then we try it with 1 plus Bob3, and we can see that results in just 1, because of course Bob3, it can't get nothing. The string must start with a number. See, when the string begins with a number like this one, 1 plus 10 cats as a string. See, 10 cats is a string, and but because that begins with the number 10, it can do something with that. See, that results in 11 here, because it just takes the beginning bit 10 and it uses that. So if the string begins with a number, then it can convert that to an integer or to a float, whatever it needs to fulfill the equation, essentially the expression that we're running. And then if we have 10.0, then drinks, so that's a string that begins with a number plus 1, that results in 11. And the same with this one. Then we have one, the last one is 1 plus cats, and that results in 1 because of course the string cats has no numeric value, so essentially we just get left with the number 1. So next we're going to talk about arrays. Alright, so an array is a way of storing data in key value pairs, and for this reason it is particularly well suited for storing related data together in a single variable. So instead of having multiple variables to store data that's connected, you can just store it in one variable that contains an array. And arrays are traversable, so that means you can loop through an array to get at each individual value and do something through each iteration of a loop. You can do something with that value. Arrays can also have other arrays as their children. So that will create a multi-dimensional array, and the depth has no limit. So you can have an array that's children are arrays, and that children of that array are arrays, and children of that array are arrays, continuing. But of course, it's, when you get too many levels deep, it's not really the most efficient way of storing data. And if you're storing, if the array gets ridiculous in size, then that could use excess RAM and memory, and it's just excess memory, and it's just not a great way of doing things. But certainly multi-dimensional, like 2-3 levels is fine, as long as you're not storing ridiculous amounts of data in them. And arrays are 0 indexed, meaning that the first value in an array is at position 0. So let's look through some code anyway to really cement in your mind what that means. So I've got a few functions. The first is going to loop through an array and display the value. So as I mentioned, you can loop through an array, which we're doing here. We're running it through a for each loop. So if this array here had 5 values within it, for example, 5 array items within it, through each iteration of the loop, it will go through those items. So the first iteration, it will be the value in the first value within the array, so at the position 0. Then the second one will be at position 1, the third one at position 2, the fourth one at position 3, the fifth one at position 4, etc. And also what we're doing here is we're checking, is the value an array? So remember I said that you can have arrays that have children that are also an array, so or that are also arrays. So of course we want to check when we're looping through this array item, when we at any position, is that child an array itself? Because if it is, then we want to loop again. So and what we're doing here is called a recursive function. So essentially we're calling the function from it within itself, so it will go as many levels deep as it has to, because when it calls itself for this value, essentially is running the same thing again, and then it will check this value's children array items, so until it reaches however many levels deep it has to. And if not, it's outputting the value. And this is the similar function, but this is outputting the key as well. So remember I said that array items are in key value pairs, so you can get to the key as well, and that is what we're doing here. So in case you want to do something with the key, then you can get at that too by specifying it in the loop. And again, we're checking if the value is an array, and we're looping through that value again if it is an array. And next we got a loop that loops through the array and displays the type. Now you're probably thinking to yourself, I could have just had these in one function and then just had some if statements to see, do we want to output the key, or do we just want to do we just want to output the value, or do we want to display the value type? But I thought, to keep the code clear and really help you understand the basics of, help you understand the code, etc., it's better to have them separate. Whereas if in a real world situation, this might not be the most efficient way to do it. But for me to make it clear what the different options are, it's easier and definitely more clear for you if I have them separate. So that is the reason for me having them separated. So we're creating an array here, and we are running it through the function that is going to display the values, and then we're running it through the function that's going to display the values and the keys. So I'm just going to show you that to start off with, so we can have a little look at some what's going on. And we can see here, this is where we're looping through the array we created with numbers 1 to 5. So if you see, we put the numbers 1 to 5 in it. So this is, sorry, I should mention actually, the syntax for creating an array, there's two ways to do it. You can use the actual word array, and then with open and closing brackets, and then each value is entered with separated by a comma. So this will create an array with 5 values in it: 1, 2, 3, 4, and 5. And as I said, it's 0 indexed. So this will be in the key position 0. This will be in the key position 1, this 2, this 3, this 4, and which we'll demonstrate now. So we can see we're looping through it and just outputting the values first of all, but then we're looping through it and outputting the values and the key. And that's where we can see that it's 0 indexed. So the first value is at the index position 0. So the key is at is 0, not 1, because arrays are 0 indexed. Now another way to create an array, the second way is, and the shorthand way, is with the square brackets. So instead of having the word array and then open and closing parentheses, we just have square brackets. And this is available in PHP 5.4 and later. So it's fairly safe to use, essentially. And we're creating these arrays in line. So these, we can call these single line arrays because we're creating them in a single line. And essentially this will create the exact same array as this. It's just a shorthand way of doing it. So we're looping through that array again, and then we're seeing, so this is the shorthand way of creating it, and you can see it's got the same values, exactly the same. And this is the same way of creating an array. So essentially this does the exact same thing as this, but we're creating it, we're using multi-line to create it, so each value is on its own line. And when you use this syntax, so when you've got everything on its own line, it's a best practice to have a comma after the last value. Even though it's not required, it means that if you come back later in the future, it's easier to add another value and less likely to, miss out a comma somewhere. So if it's in one line, a single line array, then the comma at the end isn't really, I wouldn't really advise it. It's just not necessary. But if each value is on its own line, then I'd say, it's generally regarded to be better to add a comma at the end, because it just makes your code look cleaner, I think, arguably, and just less likely to miss out a comma if you come back and add values in more items to the array in the future. Now, when you have an array key, and if you use the same key later on in the array, then it will overwrite the first value. So you might be wondering, okay, these have got an array key, they've got array keys, but we haven't specified them, and that's because PHP will give them array keys by default, 0 index, so 0, 1, 2, 3, and they increment by 1 each time. So each value in the sequence will have an array key of 1 number higher than its previous value. But you can also specify the keys yourself. So here we're creating an array, but we're specifying the key ourselves. So we're starting with 1, and then we're starting with 2, we're starting with 3. So this will be indexed starting from 1. Yeah, but as I said, it's only for each key, it's only the last time that key is specified within the array that it is included. So essentially what that means is we got the key 3 here and we're entering 3 in it here, but then we're using the key 3 here, and the only value that is going to be under that key is this value here, because it's overwriting this value, because the key cannot exist more than once. The key can only exist once in the array. So the last time that key is specified is what that key will contain, what value will be in that position of the array underneath that key, which we can see here, because overwriting an existing item, we can see 1, 2, then the number 3, because this has been overwritten by this. If I was to remove this and go back and refresh, now we can see that it's the word 3, not the number 3. But if I add that back, then we can see it's being overwritten because we're using the same key. You can also initialize an empty array and then insert items later. So we can see here we're initializing the array and it's empty, but then we're inserting items like this. And the way you do that is you specify the variable name, then you have the open and closing square brackets, then you have the equal sign and whatever value you want to input into the array. And again, this will be 0 indexed because we're not specifying a key apart from on this last value. So you can have an array that has keys that are implicitly added by PHP, and you can also specify keys yourself, all mixed within the same array, and no problem. Of course, remembering that if you add a key that's already in there, then it will overwrite the data in that position. But otherwise, you can have name keys, implicit keys, mixture, whatever you like, which we can see here. These are the keys that are added by default, 0, 1, 2, 3, and then we've got the explicitly added key of car here. And that's another thing I mentioned actually, is keys in arrays can either be numeric, that is integers, or strings. Those are the two options. Keys can be numeric integers or strings, nothing else. And if you want to get to a single value within an array and you know its numeric position, then you can output that on its own. So for example, we know that we got 1 is at position 0 in the array because it's the first item inserted. So we can specify that here, and we can print out the value that is at position 0, which happens to be the number 1 in this case, which is here. You can also initialize a variable, an array with values initially and then add more values afterwards. So we can see we're initializing an array here with 1, 2, 3 inside, and then we're adding the value 4 afterwards, and then some more things. Again, we're mixing up with numeric keys, with name keys, etc., whatever you like. So we can see that's what we got here. We got 0, 1, 2, which are added when we create the array, and then we got 3, we got the value 4, then we're using named keys here, animal, age, type, etc. It's quite flexible with what you can do. And again, we got another array with more named keys. We're displaying single values in that. So you can see we're outputting these on their own by specifying the named key to get the value that is under this key in the array. Now array keys will be array keys will be part of valid integers will be passed to will be cast to strings or to integers by PHP automatically. So this here, this value here, this string of 0 will turn into an integer 0 because it's a valid integer, but that is as long as it isn't preceded with a plus sign, essentially, because you can have a plus sign and still be a valid integer. But in that case it won't be cast. But when you've got sorry, valid decimal integers, that is, yeah, they will be changed to, so this here will actually be an integer 0, not a string 0. But this here 08 will be a string because it's not a valid decimal integer, and we can demonstrate that now by outputting array 0, and then we can see this item's key is an integer, this item's key is an integer. See, we're outputting the string, yeah, this item's key is an integer. But I will say that even though that this is going to be turned into the numeric to the integer 0 rather than the string 0, it doesn't really matter when specifying it, because the same change happens when you specify the 0 to output that value. So obviously we're inputting this into the array at position 0 under the string 0, which is implicitly turned into the number 0 by PHP automatically. But when we specify that value with the string 0, the same change will happen. This PHP will interpret this as the number 0, not the string 0, so you can access it the same way. Anyway, if you try and use a float as a float data type as an array key, it will get turned into an integer, so it will get casted to an integer, which means anything from the period and onwards, so including the decimal point and onwards, will get stripped out. So this will be under the key 1, because this bit, sorry, I didn't mean to move that, this will get stripped off. So we can see this item will be cast to an integer, and then if we have a look, this item's key will be cast to an integer, as I said. If you use true or false as the so the boolean true or boolean false as a key, then it will get cast to the integer 1 and 0 respectively. So the boolean value of true will get cast to 1, and the boolean value of false will get cast to 0. And I'll show you that. Yeah, so we can see from boolean to integer, true's been cast to 1 and false has been cast to 0. And if you use the value null as an array key, then it will get cast to an empty string. So we can see null to empty string. This item's key will be cast to an empty string. Of course we can't see anything because it's an empty string, but just to, yeah. Now another thing about array indexing is it increments by 1 each time, but if you specify a number that's higher than the current number in the chain, so then it will start from that point onwards. So to make that clear, if you have 1, 2, 3, yeah, and you're letting PHP add the keys itself, so it will be, this will be in position 0, this will be in position 1, this will be in position 2, then you specify a key explicitly, which is number 7, a numeric key. I will mention not a named key, a numeric key. Then from that point onwards, any item will will increment from the number you specified. So they'll increment from, in this case, from 7 upwards now, not 4. So I'll show you what I mean here. These keys are added automatically, we're not specifying them, 0, 1, 2, but then we get to this point where we specified the key of 7, and then from that point onwards it won't continue with where it was going 3, 4, 5. It will continue from this point onwards, so it goes 8, 9, 10. It continues from that point onwards. But if you, for example, if you have it where the array keys are added automatically for these first 3 items, so this is 0, this is 1, this is 2, that's the position, then we use name keys, so we're naming a key of car, and then we're inserting this value. Then we continue with the numeric keys, with then we continue letting it PHP add the keys for us automatically. It will continue from the position it was in, which was 2 here. So you can see that So just make it clear, this is where we start again with, this is the second array the array I just showed you, and we can see the number 1 is at position 0, number 2 at position 1, number 3 at position 2. Then we add this value in it. We have a name key of car and inserting the value Ford. Then we go back to letting PHP add the keys for us automatically, and it continues from this point onwards. Reason being, we haven't added a numeric value ourselves explicitly, so it can continue where it is. We can add name keys; it won't affect the implicitly added keys. But if you add a numeric key, then it will affect the implicitly added keys, and that is, it will continue from that point onwards. So that's why it continues here 0, 1, 2, then we specify 7, then it continues from 7 upwards. But here we specify car, it can continue with what it was, because name keys do not affect the incrementation of the numeric keys that are added by default by PHP. Right, so now I'll move on to objects. An object is an instantiated class, and a class is a container for related methods, properties, and constants. So essentially a form of encapsulation. A nice analogy I like to use is that you can think of a class as a blueprint for a building. A blueprint for a building may contain how many rooms that building has, how many bedrooms, how many bathrooms, how many square meters it is, etc., etc. And an object is the actual physical building that is based on that blueprint. So a class will contain properties and methods and constants, etc. And an object is an instantiation of that class. So you create the class, which defines the rules and what it will do, the functionality that it has, and then to make use of that class you must instantiate it, and that will create an object based on that class. So just to make it more clear what I mean, we'll look at some code now. So we have a class here named example class, and it has some properties and methods. And just to clarify now, when I say property and method, or property or method, I'm referring to variables and functions respectively. But outside of a class they're called variables and functions, but within a class they're called properties and methods. So essentially they're exactly the same thing, they just have a different name when they're outside the class and within a class. So properties and methods can be public, protected, or private. Now if a property or a method is public, then it is accessible anywhere. Essentially it's accessible within the class it's defined in, within descendant classes of the class it's defined in, and outside of the class via an instantiation of that class, which creates an object. And there are other ways to access class properties and class methods. You can access them statically, but for the purpose of this tutorial I'm just going to talk about accessing them by instantiation. And if you want to learn more about accessing them statically, then I would suggest you head over to the php.net website and have a read on it. But for the purpose of me informing you of what an object is, we're just going to talk about accessing them via instantiation. So a protected property or method is accessible within the classes defined in and within any descendant classes of the classes defined in, but not from outside of the class, only within the class and within descendant classes. And private properties and methods are accessible within the class they're defined in only, so not within descendant classes and not from outside of the class, only within the class they're defined in. So we can see we've got one public property here, one protected property, and one private property, and we have a few methods. The first one being the __ construct method, which is a special method that is executed whenever you instantiate this class. So whenever you create an object via instantiation of this class, this method here is executed straight away each time. So it's a good way to set things up that you might rely on later on in the class, because you know that if you add it to this construct method, it will all that code will execute and set up whatever you need. Then and we can see here it's just setting this public property here. And then we have another method called set property, which sets the public property. We have another method called get property, which returns the public property. And we have another method called display property, which just displays the public property. So if we go further down, we've got some code that first instantiates the class. And to do that, you just use this new keyword and then space, then the name of the class. And we're passing in this value here, which it will be passed the constructor. So the construct method expects a value, so to pass in that value, when we instantiate the class, we must pass in the value that we want to be passed to the construct method. And we're storing the reference, so this will create an object and store that object within this variable here, and then we just dump in the variable to see the contents, which of course will be the object. Then we're running the display property method, which will display the value of the public property here, display property. Then we are setting the property to a new value, and then we're running the get property method, which will return that public property, and we're storing that in this variable here named var, and then we're displaying that variable here. So we'll just see what that does. Right, we can see this is the dumped variable, which contains this object that has 3 properties, one public, one protected, one private. And then this is the value getting displayed. So this is the value of the public property. Then we're changing the value and we're displaying it again. So we're running the get property method, and that returns the value. Then we're displaying that value. Next, we have another class that is called child example class, and this class extends the example class. So in this relationship, the example class is the parent and this is the child, or the example class is the parent and this is the descendant, or you could even say the example class is the base class and this is the child class. There's multiple ways you can refer to it, but that is the relationship, parent child essentially. And when you extend a class, which you do via using the extends keyword, then the name of the class that you are extending, the child class will have access to any public or protected methods and properties that are within the parent class, and it can access them. It can access the public or protected properties and methods, or it can even override them if it wants to, which is what we're doing here. We're overriding the construct method and changing what it does, and then we're overriding the set property method, we're overriding the get property method, and we're overriding the display property method. So if we go further down, we can see we're instantiating the child example class, and you might have noticed that there's no parenthesis here, and because we're not passing in a value to the construct method, because it doesn't expect a value, there's no arguments here, so it doesn't expect anything, we can omit the parentheses because we don't need them. We only need them if we're passing in the value to the constructor, and because we're not doing that, we don't need the parenthesis, so we have omitted them here. Then we are dumping that variable which contains the object. Then we're running the display property, which will display the contents of the protected property, and we are running the set property to change the value. Then we're running the get property, which will return the protected property. We're storing the whatever it returns in this the variable named var, and then we're displaying that variable here. And we can see that is what produces this output here. This is the dumped variable which contains the object. This is the initial value being displayed, so the value of the protected property. Then we're changing the value, then we're running the get property method which returns the value, and finally we're displaying the value that is returned from the get property method. Now, just to show you some errors that will occur if we try to access this variable, this property here, protected property, from outside of the class. You'll remember what I said earlier, that protected properties are not accessible from outside of the class. So this will cause a fatal error, trying to access a protected property from outside of the class. So if I refresh this, we'll see a fatal error. Fatal error, uncaught error, cannot access protected property, example class protected property, because it is not accessible from outside of the class. This will only be accessible from within the class or within descendant classes. And similarly, the private property will cause a fatal error because this is only accessible from within the class it is defined in. So trying to access it outside of the class will return an error. See, fatal error, uncaught error, cannot access private property, example class private property. So just comment them back out, and then the same way if we try to access a protected property from outside of the child class, we will get the same error as the first error we had, which is fatal error, uncaught error, cannot access protected property. And if we try to access the private property, which is defined in the parent class, we will get an undefined property notice because essentially this is not accessible within the child class. So as far as PHP is concerned, it doesn't exist within the child class. So we get an undefined property, child example class private property, because it is not accessible within that child class. So when we try and access it, we get a undefined property notice. And thirdly, we have a descendant examples class, and because this class extends the child example class and the child example class extends the example class, that makes this class a descendant of this class, and descendant classes also have access to any public or protected properties and methods that are defined in any of its ancestor classes. So its parent class, its ancestor class. So this class will have access to any public or protected properties or methods defined within this class and any defined within this class as well. So we can see here we are actually not adding anything to this class, but it will have these methods here defined because it's a child class of this class, and it would have any properties and methods defined here as well because it is a descendant of that class. So we are instantiating the descendant example class. We're storing the reference to it in this variable, so this will contain the object. We're dumping that variable to see what the object contains. Then we're running the display property, the set property, the get property, and finally we are displaying what is returned from the get property method. So we'll see what that does. Right, yeah, we can see here sorry, oh yeah, sorry, it's here. Descendant example class contains the public property, protected property. Of course, it's displaying this by saying example class because it's only accessible within that example class. So it's not accessible within this class, descendant example class. This is the output from the display property method, and then we're changing the value. Then we're using the get property method to return the value, and then we're displaying the value, which is what outputs this here. And again, if we try to access the protected property, just to really drill home what I mean, this will not be accessible from outside of let's just change that. Yep, this will not be accessible from outside of the descendant class, so that will cause a fatal error. Yep. Fatal error, uncaught error, cannot access protected property because it is not accessible from outside of the class. And if I try to access this private property, it will cause an undefined property error. Undefined property notice, notice undefined property descendant example class. And here below here just to really draw home again what I mean about parenthesis being omitted, we can see here that the example class expects a value because its construct method expects a value, so we have to pass in a value when we instantiate it. And this child example class, its construct method does not expect a value, so we do not need the parenthesis, so they are omitted. So that's the difference there. They're required here because we have to pass in the value. Here they're not required because we do not have to pass in the value. You can create an empty object in PHP using PHP's built-in standard class, which is spelled std_class, so std_class, 2 words, camel case. And so here we can see we're instantiating the standard class, then we're just dumping it so we can see the contents, and then and then we're adding a property to the class or to the object here. So with this line of code here, now this object will contain a property, named property, and it will have a value of this string here, and then we're dumping the object again. So that is this here. So first we're dumping the variable, and all it does is contain the empty object, and then we've added a property and we're dumping the variable again, and now it contains the object that has one property, name property, with a value of string foo. You can also convert other types to objects, so via casting the type to an object. And when you cast a different type, so any type to an object, it creates an object of type standard class, and it, depending on what value you use to cast to that object, that will determine what that object contains. So if you cast the value null, so the null constant, to an object, then it contains the object standard class will be empty. So yeah, object conversion, converted null to an object. We can see we've converted null to an object, and it contains an empty object of type standard class. If you convert a string to an object, so you cast a string to an object, which you do with this line, which we're doing with this line of code here, then it will contain one property that named Scala, that has a value of the string that we use to cast to an object. So in this case, the property named Scala will contain the string foo, which is what we have here. See, standard class, so an object of type standard class, and it has one public property named Scala with a value of foo. And with classes in PHP, if you do not, when you add properties, if you do not explicitly define whether they're public, protected, or private, then they will be public automatically. So so in that sense, this Scala property that is created by the string that we use to cast to an object will be public. And if you create a property like this way, using the object, so the instantiated class, it will be public as well. But I would suggest that when you create properties or methods within a class, you always explicitly define whether they are public, protected, or private. Even though you can, if you want them to be public, you can just leave them without that being defined, and they will automatically be public. I think it's better to explicitly define it. Of course, that's up to you, but that's just my suggestion. If you convert a boolean true to an object, it will create an object of standard class with one property named Scala again, and it will have a value of true. So that is this here. It's created an object of type standard class. It has one public property named Scala that has a value of boolean true. When you convert an array to an object, then the array keys and value pairs will become properties and their values. If the array keys are numeric, then to access them you must loop through the object, and then through each iteration you can access the value. So it will allow you to access the value one at a time through each iteration. Now you can also access properties that have named keys, so properties that if the array has named keys within it, then you can also loop through, and then you create an object from that array. You can also loop through those values, but you can, as well as being able to loop through them, you can access them via the property name, because the property name will be what the variable name was. But that's only if you use name strings. For numeric strings, you can only access them via running the object through a for each loop and through each iteration. So we can see that's what this code here is doing. First, we're creating an array, and the first three items 1, 2 and 3 will have numeric keys, so integer keys of 0, 1, 2, and then this fourth item has a string key of car. So this will be the only one that's accessible via the property name. The other first three items you'll have to loop through the object. So we're casting this array to an object, and then we're dumping, it's being stored in this variable, then we're dumping the variable, then we're looping through the variable and printing each item for each iteration. We're printing the key and the item, and then down below we're accessing the property that has a name of car via using the property name, because of course this array item here has a string key, so we can access it via its property name, because when we convert this to an object it will have a property with a name of car, and we can access that via its name. So we'll see what that does. First, this is the dumped object of type standard class. We can see it's got 4 public properties. The first 3 are named 0, 1, 2 because those were the keys of the array. 0, 1, 2 the integer keys, and the last one is named car because we had one string key that was named car. And then we're looping through the object here, and through each iteration we're displaying the value, so we're displaying the key and the value. So here's the 0 key, which has a value of 1, the property and value. So here's the 0, the property 0, and it has a value of 1. Here's the property 1, and it has a value of 2. Here's the property 3, and it has a value of 3. And then here is the named property, which has a name of car, and it has a value of Ford. And then this is the final output, where we're outputting the property using its name. So that is this line here. We're outputting the property using its name, which is car. Right, so next we will move on to callables. Right, so let's just open up this file here. And yep, the callable type is characterized by its ability to be used as a callback function. Any user-defined or built-in function can be used as a callback function, apart from language constructs such as array, echo, empty, eval, exit, isset, list, print, or unset. The most common way to execute a callback function is using the call user function or call user func array functions. Now I just will dive into looking at some code to clarify what I've just told you. So the first callback function we are using is this one here that I've created, named simple callback function, and it expects one value to be passed into it. And then here we are going to use that function. So as I mentioned, you can use a callback function via the call_user_func function, and the first argument is the name of the callback function, and the second argument is a string that we are going to pass in, or that will be passed in to the callback function. So this is the name of the callback function here, and this value here will be passed in to the function here. So yeah, that's it. You know, it's the callable type is just essentially just define something that you can call. Essentially, that's what it's characterized by, its ability to be used as a callback function, which is what we're doing here. So yeah, let's have a quick look at what that does. So yeah, that produces this output here, an example of a simple callback function. Because we are defining the callback function here, a simple callback function, then we are using the call user func function to execute that callback function, which passes in a string here, which is then in turn output. Another way to access a callback function rather than just passing in the name is if you have a callback function within a class. So here we have a class with a name of A, and then it has a callback function. So it's callback function within class is the name of the function, and then we pass in a value, and or actually this time the argument has a default value. So when an argument to a function or method has a default value, then you do not need to pass in that argument. It essentially makes the argument optional. So when I run this function, it means I can optionally add in an argument, but if I do not, then the argument, which is this here, will get a default value, which in this case is 1. So if I run this function and do not pass in a value, then it will have the value of 1, and then the function just returns the value and multiplied by 10. So by default it will return 1 multiplied by 10, but if we pass in a value, say 2, then it will return 2 multiplied by 10. So a couple of ways to access a callback function within a class. The first is to instantiate that class, which we are doing here. See, new A creates instantiates that class, and it creates an object, and then the object is stored in the variable class underscore A, and then when we run the call user func function, when we execute that function, we pass in an array as the first item. So the first argument is an array, and the first item in that array is the instantiated object, the instantiated class, so the object essentially, and the second argument is the function that we want to call, or the method we want to call, that is within that object. So first argument is an array with an item of the object, and the second item of the method within that object, and then the second argument to the call user func function is any values you want to pass in to that method that you are running. So as I mentioned earlier, we do not need to pass in an argument, so we are running this function, this method twice. The first time we are going to pass in a value of 2. The second time we're not going to pass in any value. So this method here is going to be executed twice. The first time it's going to have a value of 2 passed in, and the second time it's not going to have any value passed in, so it will just have its default value of 1. So if we have a quick look at what that does, we can see here the first time it's called, it has a value of 2, which if you remember correctly, the method returns the value passed in multiplied by 10, so 2 multiplied by 10 equals 20, and then when we don't pass in a value, it has a default value which is 1, so it returns 1 multiplied by 10, which of course is 10. Then another way to access a callback function that is within a class is to access it statically. So that's what we're doing here. So when you want to access it statically, you execute the call user func function, and the first argument is an array with the first item in the array being the class name, and the second item being the method that you want to execute. And then the second argument to the call user function is any arguments that are going to be passed to the method that we are executing. So this here is going to execute this method here. So we have a class called B, and we have a public function here, static callback function within class. And again, this has a default value of an empty string, but if we look, this method here, it returns the string passed in, but it returns a substring of the string passed in, and essentially with the first 22 characters removed. So running this method with an empty string wouldn't make much sense, because you can't return a substring of an empty string, because there are no characters in it. It's an empty string, so it wouldn't make sense to execute that without an argument. So here we are so we can see that this string is being passed in here, and the first 22 characters will be removed, which is this. So it will return this here from the function, which is stored in this variable here. Then we are just printing that variable. So we can see it returns an example of a static callback function is the part that it returns. So essentially this bit is stripped off, this first bit, so it just returns this bit here, which is what we're seeing here, an example of a static callback function. Now there's another way to access a method statically, that is, and this syntax is available since PHP 5.2.3, and that is to again run the call user function, but the first argument is not an array this time. It is the class name followed by two semicolons, or two colons I mean, and then the method name. And again, we're passing in a variable as the second argument to the call user function. And like the first argument, this bit here will be removed, so all that will be returned is this bit here, alternative syntax, blah blah blah. So when we run this method, this display value here with the result, it will contain just this here, which is what we are seeing here, alternative syntax for executing a static callback function. Okay, you could execute protected and private callback functions from within the class they're defined. Of course, with protected ones it can be within descendant classes as well, but with private ones only within the class they're defined in. But yeah, so protected and private callback functions can be executed within the class they're defined. So here we are instantiating this class here, which has a name of C, which we can see is up here. When we instantiate it, it's going to run its construct method, which if you watch the previous step of this tutorial, you'll remember me saying that when you instantiate a class, its constructor method, so its underscore underscore construct method, is executed immediately each time. And what this does here is it accesses it loops through this protected functions property, which contains an array with two strings, the first one being function A, the second one being function B, which are the names of the functions that this, or the names of the methods that this class contains. So through each iteration it will pass the function name to the call user function, and which will execute the function or method. So and again, you probably remember me saying that when inside class, you can reference that class using this variable. which is just a better way, because it means if you change the name of the class, you don't have to worry about that, because you're accessing it via the this variable rather than using the name of the class. So when we execute this call user function, we're passing in an array with the first item being a reference to the class, which is the this variable that we're using, and the second argument is the name of the method that we want to execute, so the callback function we want to execute. And then we're passing in this value here, so which is just a string, and then you can see that function A will just display the value that is passed in, which is this inside of, and then it just will run this bit of code here, which will display the name of the method. So when within a method, you can use this here, underscore underscore method uppercase and underscore underscore, which will return, which is a constant that will output the name of the function that you're within, and the function B does the same thing. So when we instantiate this class, it's going to run its construct method, which loops through the functions property, and the functions property contains an array that has the names of two functions that are within this class. And through each iteration, it's going to run the call user function, passing in an array as its first argument, with reference to the class that we're within as the first item in the array, and the second item being the name of the function through this iteration. And then the second argument to the call user function is a string, and that will be passed to the function being executed, which will be this, the first iteration of the loop, and this, the second iteration of the loop. And then each function just displays the value passed in, and also concatenates the underscore underscore method underscore underscore constant to the value that is displayed, and that produces this output here. So we can see inside of, the first time it's the function A property that is inside the class C, and second time it's the function B property method, sorry, not property, method, that is inside of the class C. Now, last but not least in this section, we have another way of executing callback functions, and that is using the array map function that is a built-in function to PHP. An array map essentially accepts two arguments. The first argument is a function or reference to a function, and the second argument is an array. And what it will do is it will execute the function using each item in the array. So what it will execute the function one time for each item in the array. So in this case, we're just using a simple function that is stored in this variable named square, and what it does is it returns the item passed in to the power of itself. So passing in an argument to the function, and it will return the item to the power of itself, which essentially is squaring the item. So we're creating an array with the numbers 1 to 10, and then we are passing in that array to the array map function, with the first argument to that function being the square. So the first argument to the array map function is the square variable, which contains this function here, and then the second argument is the numbers variable, which contains an array of 1 to 10. So essentially this function is going to be executed once for each number 1 to 10, and it will square that number by multiplying it by itself, which produces this output here. So this is 1 squared, this is 2 squared, this is 3 squared, this is 4 squared, this is 5 squared, this is 6 squared, this is 7 squared, this is 8 squared, this is 9 squared, and this is 10 squared. So it's a cool way if you want to run a method on a bunch of items in an array. Then the array map function is a very handy function to use. Now we will move on to iterables. Iterable is a pseudo type available since PHP 7.1. An iterable type accepts any array, and it also accepts objects that implement the traversable interface. So it's just, you can use it for multiple things like type hinting, that will make sure that so you could type hint an argument to a function, and it will make sure that the argument to that function is iterable, essentially. So something that's iterable is an array or an object that has certain properties and methods, etc. And yeah, so let's have a look at some code using an iterable parameter type. So here we have a function named foo, and we're just type hinting its argument as iterable. So what this means is anything that we pass in to this function has to be iterable. So that includes, as I said earlier, an array or an object that implements the traversable interface, whether directly or, well, actually it won't be directly, it'll be indirectly, but we'll clarify that shortly. So for now, we'll just see that we're passing in an array that contains the numbers 1 to 5. So we can see the output that produces. So we can see, yeah, this is the output that produces, because what we're doing is looping through the passing argument and then just displaying the value for each iteration, which is 1, 2, 3, 4, 5. Now, if you try and pass in an argument that is not iterable when we've type hinted that the type must be iterable, which is what we're doing here, then you will get an error. So if I just show you the error now, we can see fatal error, uncaught type error, argument 1 passed to foo must be iterable, and we're passing it in the string. So it expects something that is iterable, and it is not. In this case, we're passing it in a string, which of course is not iterable. Because iterable means you can iterate through it, so you can run it through a loop, for a for each loop, and you can get at the values within it. So obviously, of course, things like arrays and objects that have certain characteristics. Another thing you can do with iterable is type hint a return value. So in this case, we're type hinting this return value here as iterable, and of course we are returning an array which we know is iterable. Of course, we know what we're returning is iterable. So, and then we're running this function here through a for each loop, which will have, for each iteration, will have one of these values. So Audi A5 blue 2015 6000. So we can see what output that produces. Yeah, we can see for each iteration of the loop we have one of these values, and then we're printing them. And similarly, if we try and return something from here that is not iterable, then we will get an error. So if I try to return string, for example, that will cause an error. So here, fatal error, uncaught type, return value of bar must be iterable, and we are returning a string which is not iterable. So just put that back to what it was. So remove the error. Now, as I mentioned earlier, another way of making an iterable type is to implement an interface. So we have to implement the traversable interface, but we do not implement that directly. We implement it via another interface that extends the traversable interface. So we cannot implement the traversable interface directly, yet we have to implement it via an interface that extends it. And there's two options for that. The first option is the iterator aggregate interface, which extends the traversable interface, and both of these interfaces that I'm mentioning and the third one that I'll mention shortly are built into PHP. And an interface, essentially, I'm not going to go too much into that because that's not really for the purpose of this tutorial, but to be brief, it defines the characteristics that a class must contain. So if a class implements an interface, then that interface will define the its signature, essentially, what it should contain, like what methods it should contain and what variables, etc. But not the definition of those methods, just that it needs to contain those methods, and then it is up to the class that implements the interface to actually define those methods. So in this case, we must define this getIterator method, and we are returning a new arrayIterer, an instance of the arrayIterer class, and we're passing in a reference to the class that we are inside of using the this variable, which, as I mentioned earlier, is a way of accessing the class when within it. And then we are instantiating this class here, and we are looping through its values and just displaying them one at a time, so it will display all of these properties. So yeah, we're looping through its properties, and we are just displaying them one at a time as we loop through them. So we can see, yeah, that's this, implementing the iterator aggregate interface, and we're displaying the value for each iteration. We're displaying the value of the current property for that iteration, which is 1, 2, 3, 4, and 5. Now, finally, I'm going to show you an implementation of the iterator interface, which again extends the traversable interface. So this interface extends the traversable interface. So essentially, this class here, my iterator, implements the traversable interface, but indirectly. And this requires that we define some methods. So the first is the rewind method, current, key, next, and valid. And also it has the we're using a constructor to set an initial value for a property, which is the position property. And then it also contains another property, which is an array that has 5 elements within it. And then here we are instantiating this class that we've named myIterator, and then we are looping through it, which will loop through all of its properties in the array property, and which will loop through all the items in this array property, and output them here. We're displaying the key and the value. So we can see that is producing this output here. So for the first iteration, we're displaying the element, and the way we're doing that is via the position property. So we can see we're giving the position property an initial value of 0, and then when we loop through this iterator, we can run the methods each time. So the next method will increment the position variable by 1 each time, the position property by 1 each time, and we can see that these other methods do other things, like current will return the and then we're using the value stored in the position property to access certain items in the array. So it has an initial value of 0, which will be the key for the first item, then 1 will be the key for this, 2 will be the key for this. So you can see when we're incrementing the value, the current value by 1 that is in the position property, we can use that value to access the certain items in the array using its key. And which is what we're doing. So we can see here, and then when we're looping through that, you can see that the order that the methods are executed in. So first it's the rewind, then it's the valid, then the current, then the key, and then and then we can see it's next, valid, current, key, etc., etc. So now I'm going to talk about a resource. So a resource is a special variable which holds a reference to an external resource. these resources are created and used by special functions. An example which is the image create function, which creates a GD resource. So as always, we'll look at some code. Now we can see here that we are using the image create from JPEG function, which is a built-in PHP function, and we are passing in a file path to a JPEG image, and then what this will do is will return an image resource, and we are storing that in this variable here. So essentially, when we create this image resource, then we can manipulate that resource and then do things with it, and then save it, for example, as a new image. So the image resource contains a reference to a file, and it will not a reference to a resource, which is in this case is a file. And when we manipulate that resource, it will not affect the original file. Yeah, we can make our changes to that resource, and then we can save it as a new file without affecting the original file. So that's what we're doing here. We're creating an image resource based on this file here. Then we are saving it as a ping using the PHP built-in function image ping. And we're obviously the first argument is the image resource, and the second argument is the name for the file, which in this case is we're just using the timestamp, and then of course the .png extension, because it's a ping image we're saving, because we're using the image ping method. So we'll have a quick look, see what that does. If we actually, first of all, I'm going to show you. Okay, so this is the file we're passing into the image create from JPEG image. So we're creating the path to this image, this camping.jpg image, which, if you remember correctly, camping.jpg, it's in the same folder as this file. And then we are going to save it. So if I navigate to the resource page, we can see, you can see we're dumping the image resource variable. And then if I go to this folder here, we can see it's created a new image, and it's got its name as a timestamp, and it's got the extension .png because it's a ping image, and that is created by this by executing this image ping function. So that is what a resource is. Last but not least, we're going to look at the null type. The special null value represents a variable with no value. A variable is considered null if it has been assigned the constant null, has not been set to any value yet, or has been unset using the unset function. So if we have a look at some code here, we can see we're setting a variable here named var1, and we're assigning it the value of the constant null. Then we are initializing a second variable named var2 with no value, so we're not giving it a value when we initialize it. Then we're creating a third variable named var3. We're passing in a string, so we're inserting a string into it, initializing it with a string, and then we are unsetting it, which essentially makes it have a value of null. So we have a quick look at what that does. We can see this is the first variable which we assign the constant null to, and this is the second variable which we initialize without a value, and this is the third variable which we initialized with a string, and then we unset it, which makes it null. So all three are null. Now, you can test if a variable is null in three ways. The first way is by using the isNull built-in PHP function and just passing in the value that you want to check. The second option is by comparing the value to the null constant using the two equal signs, which just compares the value. And the third way is comparing the value to the null constant but using three equal signs, which compares not only the value but also the type. So for example, an empty string is seen as equal to null if we're just checking the value. So an empty string will pass this check here, but an empty string will not pass this check because this will check the value, which will pass, but then it will also check if is it the same type, which will fail, because of course an empty string is not the same type as null. Only null can be the same type as null. So with that said, we are creating an array and we are inserting it into this variable named array, and the array has the following items. First, it has the var1, which has a value of null. The second item is an empty string. The third item is an empty array. The fourth item is the boolean false. The fifth item is the boolean true. The sixth item is an integer of 0, and the seventh item is a string 0. 1, 2, 3, 4, 5, 6, 7. Yeah, that's correct. Okay, and then we are looping through that array, and through each iteration we are checking the value using these 3 different methods. We are checking if the value is equal to null. So first we are checking using the isNull PHP built-in function. Second time we're checking with 2 equal signs. The third time we're checking with 3 equal signs. And if it passes this check here, the isNull function, then we are outputting this string. Whatever value is passed in then is equal to null and of the same type. If it fails, then we are outputting this string here is not of the same type as null. Then if it passes this check here, which just checks the type, then we're putting is equal to null. And if it fails, we're putting is not equal to null. And then this third check, if it passes this, then we're putting is equal to null and of the same type. And if it fails, then we're putting is not of the same type as null. And this check here is the same as this check here. So this checks the value and the type. So when it fails this check, this could be because it's not the same type as null and it's not the same value as null. But for the sake of this, we're just going to put is not of the same type as null, because that will suffice for the purpose of this. So yeah, we're going to loop through it. We're going to check each value and we'll see what that does. Yeah, we can see first we're checking the value null with the isNull function, and of course null is equal to null and of the same type. Then we're checking it with the 2 equal signs, which passes null is equal to null. Then 3 equal signs, null is equal to null and of the same type. So it passes all 3 checks, because of course null is null. So it's going to pass all 3. Then the second item we're checking is the empty string, and this will fail the isNull, the check using the isNull function, because it is not of the same type as null. So this would be considered the same value as null, but not of the same type. So it fails this check. And because it is seen as the same value as null, when we check using the 2 equal signs, it passes that check. So empty string is equal to null. But when we check with the 3 equal signs here, the same way that this check fails, this check also fails, because it checks the value and the type. Then if we check an empty array, because it will fail this check, it's not the same type, it will pass this check because an empty array is seen as having the same value as null, and it will fail this check again because it's not of the same type. False is fails this first check because it's not the same type, passes this check because it is seen as equal to null, and it fails this check because it's not of the same type. True fails this first check. In fact, true fails all 3 checks. So true fails this check on both things that it checked. First, it checks that it's the same value, or well, it checks is it the same value as null, and it's not, and it also checks is it the same type, and it fails both, because it's not seen as the same value as null, and also it's not seen as the same type. It fails this check because it's not seen as the same value, and it fails this check. So of course with these checks, if any item fails this check, then it will be impossible for it to pass these checks. 0 fails this first check because it's not the same type. It passes this check because it is seen as equal to null, and it fails this check because it's not of the same type. And the string 0 fails all 3 because it is not the same type, and also it's not seen as the same value. So we've reached the end of the video. I hope you found this video informative and it helped you gain some knowledge and some information about PHP. If it did, and you did find this video helpful, then I'd appreciate if you shared the video. If you know someone else can benefit from watching this video, then you should share it with them. And if you want to see more videos like this, then you should subscribe to my channel. If there is not if the next lesson has not been output yet, so lesson 4, then don't worry, it'll be up on my channel soon. I'm trying to make at least one video in this series each week. So, you know, if you check back tomorrow or the next couple of days, you should see a new video. But also, if you subscribe to my channel, then and you set it up so you get notifications when I upload a new video, then as soon as I upload a new video, you should get an email or you know, a notification, and so you don't need to worry. As soon as a new video's up, you'll know about it. And yeah, until next time, take care.